Inferential Data Analysis, Part 2. Slide 2. Keeping with my efforts to keep my podcasts brief, this is what I'll be going over today, and in this order. Slide 3. First of all, what is a meta-analysis? A meta-analysis is a way of combining a number of studies that are similar into a single analysis that helps us to determine the effectiveness of similar interventions or the presence of difficult to research phenomenon. Meta-analysis truly are for smarty pants. The difficulty that a lot of social work related research has is that it gets conducted on small sample sizes. The trouble with small sample size studies are that they often fail to arrive at statistical significance, while they may have at the same time a fairly robust effect size. You may think that something is going on in your data because we see the strong effect size, but our small sample size and lack of statistical significance still leaves everything open to chance. However, if you can bring together a number of smaller studies that are similar in their composition, then through the reasonably easy process of mathematics we can combine all of the studies and analyze them as if they were one. Since one of the primary concerns of a small sample size is the committing of a type 2 error, a meta-analysis helps to alleviate those concerns. It is always dangerous to rely on a single study, and sometimes when we qualitatively look at a number of journal articles written about separate studies, it's hard to make any definitive statements. By conducting a meta-analysis, it is not always possible, as it may lack sufficient number of studies in any one area of interest. And that is oftentimes, we have findings that contradict one another. Slide 4. Just like any other research project, the meta-analysis needs to be systematically laid out. It is important that we define the criteria for including studies in our meta-analyses before we go looking for articles to include. We need to be careful that we are not judging a strong study the same as a weak study. Furthermore, we need to be careful what we are comparing. Furthermore, we need to be careful that we are comparing studies that have similar methodological quality. A random assignment in a controlled study with double-blind placebo is just not the same as a two-comparison group study based on convenient samples. We need to be careful of conflicts of interests in evaluating the studies to be included in a meta-analysis. For example, several years ago, or even a decade ago, I heard about this study raising concerns about children reusing water bottles in Canadian public school districts. The concern was that they were finding high levels of fecal bacteria in their water and water bottles. A perfectly fine study, however, it was sponsored by a Bottled Water Association. Their intent was to show that the bottled water is safer than the tap water. What they didn't count on finding was that many school children were reusing plastic bottles, and the researchers speculated that the children were contaminating the plastic bottles from the fecal material on their own hands. In the text, we read about concerns about studies conducted by cigarette manufacturers. Of course, cigarette smoking is pretty much settled science at this point. However, the current big industry sponsoring research is big oil and coal. The Koch brothers apparently have been funding several select scientists in the campaign to debunk global warming science. Just like many other areas of investigation, follow the money and you'll get your answer. Just what is meant by the file drawer effect? It is that many studies, if they do not find statistical significance, or if they find statistical significance but the outcome is not in favor of an effective intervention, the study gets quietly placed into file drawers. Or in the modern case, they may end up on some internet cloud someplace. The problem with that is that only the studies that show both clinical significance and statistical significance make their way into the published articles. Then the meta-analysis will be skewed towards effectiveness. It is very difficult for us as independent researchers to find a lot of unpublished manuscripts. Slide 5. So, while you might not be conducting a lot of meta-analysis in your near future, you could very well be using them in the process of deciding a best practices investigation. Therefore, just like any other piece of literature that you may obtain from the library website, you need to be critically appraising the value of the meta-analysis. You want to make sure that the process was done in a transparent manner, meaning, did the authors have any sort of conflict of interest or other biasing factor? If the authors did not state a conflict of interest, it might be important that you assume they possibly have one. Of course, if they state a conflict of interest, you will want to carefully examine their methodology. What kind of studies did they include? Did they only include methodologically sound studies? What about unpublished studies? Ask yourself, what efforts did they go through to find those file drawer studies? And finally, how comprehensive were they? Does the meta-analysis only look at one aspect of the treatment or of a condition, without taking into consideration all ways of treating the same condition? Slide 6. The importance of statistical power analysis is in detecting type 2 errors. It has been steadily increasing in the social work literature. Therefore, you should be familiar with it, even if you may never do a statistical power analysis on one of your research projects. If you remember from the previous chapter, a type 2 error is the failure to reject a null hypothesis when it is in fact true. In normal speak, a false null hypothesis is when there is an actual difference between your intervention group and your control group. When you fail to reject that false null hypothesis, it means that you are failing to recognize that there is a difference between the control group and the intervention group. Potentially, that leaves you missing out on a potentially effective intervention. So you can see that detecting a type 2 error and taking steps to eliminate it in your own research is important. Like a type 1 error, a larger sample size will reduce the risk of committing a type 2 error. But an overly large sample size comes with its challenges as well. Slide 7. Doing a statistical power analysis involves some fairly complicated math. Fortunately, the originator of statistical power analysis has created tables to help us estimate the size of the sample that we will need in order to get good assurance that we will not commit a type 2 error. Excuse me. So in the last podcast, when I said that my response to the question, how large should my sample size be, I amend my response and say, it depends. Let's check the power analysis table. Slide 8. Computing statistical power analysis is complicated. However, Cohen has constructed some tables that provide power analyses. This is an example of one of Cohen's tables for a power analysis of testing the significance of correlation coefficients at the 0.05 and the 0.10 levels for small, medium, and large effect sizes. The figures in Cohen's table are approximately the same as this one. So these estimates may be used to approximate power analysis for studies that use a different test of significance. Let's say you choose a 0.05 significance level. The red arrow. The first step is to choose a significance level and estimate the strength of the correlation or effect size between the independent and dependent variables in your study. The average strength of effect sizes found in clinical social work outcome research is an R-square of 1.0, which corresponds to a medium effect size, seen here in the green box. The column is the probability of correctly rejecting the null hypothesis. As the sample size increases and the effect size increases, so too does the possibility of correctly rejecting the null hypothesis. A higher number corresponds to a stronger level of power. A sample size of 10, see the blue box, will only have a probability of 13, meaning that 87 times out of 100 we will be exposed to committing a type 2 error. Typically, it would take about 200 people in our study to eliminate a type 2 risk. Notice that power may also be increased by setting a less stringent significance level. For example, a significance level of 0.10 might be chosen over 0.05. However, this approach increases the risk of a type 1 error. Slide 9. Power analyses are most useful when conducted in the planning stage of a study to ensure sufficient sample size. However, performing a power analysis after the completion of a study may help to explain null findings. In other words, if the study results show no difference between a group who receives a treatment and a group who does not receive a treatment, and no difference are found with regards to outcomes, a power analysis would provide an estimate of how likely it was that there was a true difference, that the current study was not powerful enough to detect. Slide 10. There are a lot of different statistical tests available for the researcher to evaluate their data. The criteria that go into selecting which test you use is determined by the type of data that you have available to you. What is the level of the measurement of the variables? A nominal level variable will demand a different type of analysis as a ratio. Furthermore, if you are just analyzing one variable, you have a limited number of options. Whereas if you have two variables, you might choose from a broader array of statistical tests. And finally, if you have three or more, then your choices grow exponentially. Furthermore, if you have a nominal variable, the kinds of tests that you do will be determined by the number of categories in each nominal variables. Sampling makes a difference, whether or not your variables are parametric. Slide 11. The gold standard of a statistical test is one of the many parametric tests. There are assumptions behind parametric tests, that at least one of the variables is either an interval or ratio level measurement, that the sampling distribution is normal, and that there has been a random selection process. Slide 12. The t-test is appropriate for a dichotomous nominal independent variable and an interval or ratio level dependent variable. An analysis of variance, or ANOVA, is appropriate for situations where there are more than two categories for the independent variable. However, the dependent variable must still be either interval or ratio level data. The chi-square is used when both the independent and dependent variables are at the nominal level. It assesses the extent to which the observed frequencies are different than what would be expected if the distributions were created by chance. Fisher's exact test is like a chi-square, but it is used when the sample size is too small to use a chi-square. There are many other different tests of statistical significance that are indicated in different situations. Slide 13. Oftentimes, in the study of social work types of interventions, we must rely on some form of multivariate analysis. This is often the case because we rarely do one single thing at a time, or the thing that we do has an effect on multiple things. Say, for example, you decide to add some sort of a case manager broker type of function to your family preservation unit. This case manager does a lot for the family, one of which is provides transportation. So because the person has reliable transportation, they are able to get to their parenting classes, their substance abuse counseling, the children's therapy, etc. And perhaps it is really those other things that are making the improvement. But oftentimes, we only end up studying the simple thing that we change. Slide 14. In multiple regression analysis, the object is to determine how much of the variance, the dependent variable, represented here by the purple circle y, is shared with the independent variable x1 and x2, represented by the green and light blue circles respectively. As the picture shows, some of the variance of y overlaps with x1 or x2 alone. Some of the variance overlaps with both the independent variables, and some of the variance remains unexplained. Slide 15. The lowercase r represents the proportion of variance explained by one independent variable, as in correlation, whereas uppercase R squared represents variation that is explained by the entire set of independent variables. A standardized regression coefficient or beta weight statistic are also calculated in multiple regression models. The higher the beta weight, the greater the effect of the predictor variable on the dependent variable when all other predictor variables are controlled for. Multiple regression also tests for the statistical significance of each beta weight, thus identifying which particular predictor variables are significantly related to the dependent variable after holding all of the other variables constant. Discriminant function analysis is similar to multivariate regression and has similar statistics, but it is used when the dependent variable is dichotomous. Slide 16. Path analysis is a causal model for understanding relationships between variables based on regression analysis. In this type of analysis, the values of one variable are assumed to cause the values of another variable. Specifying which variables are independent and which are dependent is essential. In this example of a model that might be tested by a path analysis, it is hypothesized that physical abuse directly predicts school failure, but also directly affects school failure through its effect on behavior. Typically, path diagrams are much more complex than the model suggested here. The strengths of relationships are calculated from a regression analysis called path coefficients and represent the strength of the relationship between the two variables, with the effects of all other variables held constant. Slide 17. Type 3 errors can happen when the same construct is captured by both the independent and dependent variable measures. For example, if you hypothesize that caregiver burden is reduced when caregivers have strong informal support system, but your measure of caregiver burden includes items that quantify the strength of the support systems, you have created a tautology, basically measuring the same thing. Another problem might be demonstrated by another study of caregiver burden. Suppose you survey caregivers about their experience of burden using a standardized scale that yields a score indicating level of burden, and you find no difference across caregivers who are caring for people with AIDS versus people with severe and persistent mental illness. You may incorrectly assume that the experience of burden is the same for both groups, when what is actually important is the quality of the burden. Caregivers of people with AIDS might be more burdened by the shame they feel about their loved one's illness because of the social stigma attached to the disease. Caregivers for people with severe and persistent mental illness, on the other hand, are more burdened by their sense that they are somehow responsible for their loved one's illness. Qualitative data can provide a deeper insight into some of these problems by providing deeper insight into important relationships and meanings that may not be captured by quantitative data. Slide 18. Inferential statistics are commonly misused and misinterpreted, most of which has been discussed above. Power analysis should be conducted before a study to prevent designing a study with too little power to detect expected effect size. If the null hypothesis is rejected, this finding provides evidence in favor of the hypothesis, but it does not confirm it. There is always a chance that the observed relationship is a product of chance. Statistical significance is the estimate of the likelihood of making a type 1 error, but provides no measure of the strength of a relationship between variables, nor does it provide information about how meaningful the relationship is in the real world. Finally, performing multivariate tests can result in inflated type 1 errors. For example, if we choose a significance level of 0.05, that means for every 100 analyses that are performed, 5% of the statistically significant relationships observed are a product of chance. By chance, 1 in 20 bivariate analysis will result in one falsely statistically significant relationship. Slide 19. Some statisticians believe that statistical significance is irrelevant unless all of the assumptions of the chosen test of significance are met, including perfect random sampling or random assignment and no missing data. Other statisticians see testing for statistical significance as a first, but not sufficient step in the inferential process. Design issues regarding sampling techniques, measurement error, etc. must be considered. The significance level is interpreted as the probability that the null hypothesis is true. However, the analysis is not over. Informed judgment is then used to weigh the generalizability of the study findings. In social work research, generally speaking, the constraints make it extremely difficult to meet all assumptions of statistical significance tests, particularly those that require perfect random assignment and no missing data. Some argue that significant tests only apply to samples, not entire populations. With a population, there is no sampling error. All possible cases are captured. Any observed relationship generalizes to the population. Other statisticians argue that significance tests do apply when analysis moves beyond bivariate association to attempts to explain the variation in a dependent variable. Stop already, would you? I will.